Join me as we explore solving linear equations. In this lesson, we'll be looking at 5 main types of linear and simple equations. The lesson will be presented in 4 sections in which we will cover the following. So we're going to be looking at linear equations with one unknown, then linear equations with an unknown on both sides of the equation, linear equation with brackets, then linear equations involving fractions, and the final section will be solving equation with exponents and roots. Guys, it is important not only to subscribe, but to hit the notification bell, selecting all, so as to avoid missing any future section of this lesson. So, now let's start by looking at what is a linear equation. A linear equation is an algebraic equation where each term has an exponent or power of 1. This means that if we look at the equation, there will be no visible power, because when we've got a power of 1, we never usually actually write the power as 1, we just leave it as it is. Now, when this equation is graphed, it is always resulting in a straight line, and this is the reason why they are called linear equation. The word linear comes from the word line. So I've put here an example of what this equation would look like should we have plotted it on a graph. And also, if we look here, 2x plus 5 equals 10 is an example of a linear equation. Now, if we look, we can see that there is no power, or there is no what we call exponent. So exponent is just another way of saying power or index. So key point here is to make sure that we are able to identify a linear equation. It will have no powers visible. So we go on to look at linear equation with one unknown. So to solve a linear equation, or we say a simple equation, this means that we are finding the value of the unknown variable. We do this by performing the opposite of the operation of what is given in the equation. So for example, if in the question we are multiplying, we would then do division in solving. Another example is that if we are adding in the question, we would have to do subtraction in order to solve the equation, and so on. So here, we're focused on the inverse of the operations given in the question. So let's talk a little bit about balancing equation. Importantly to note is that an equation is like a scale. Whatever you do to one side of the equation, you must also do the same to the other side in order to keep that balance. So therefore, if I should subtract a value from one side of my equation, I would also need to subtract the same value from the other side to maintain that balance. And oftentimes you may go to the park and you and your friends, you are on that seesaw. You can see the effect of, if you've got one side heavier than the other, then there is going to be an imbalance. And so to maintain the balance, we do the same thing on both sides. Beautiful. So here now is an example of my balance scale. So on one side I've got x plus 5, and on the other side I've got 9. What I want here is to make both sides being equal. So therefore, when I talk about solving an equation, what I'm really doing is looking for the value of x that makes the equation true for both sides. So therefore, if I've got 9 on the right hand side, I also need to have 9 on the left hand side. So what is the value of x that makes both sides add to 9 is what I'm after. So if you want to solve for the variable x, you would need to make x be alone on one side of the equation. To do that, we must balance the equation by doing the opposite of the operation. So in this bit here, given on the scale, we would have needed to do the opposite of plus 5 on both sides. But we're going to get into some examples and we're going to execute the balance method here. Amazing. So for the first one, we've got here unknown in one step. So we're going to solve unknown in one step. We also have one unknown. So we're asked here to solve each of the following linear equations. First one, A, is w plus 5 is equal to 27. So what we need to do here is to identify the operation that we're already given in the question, which we can see here is plus 5. So I'm going to rewrite my question. I've got w add 5 is equal to 27. I love to write what I have. So I've got a plus 5. I need to do, so D is for do, H is for have. I would need to do a subtraction of 5. So we remember we need to do that on both sides. So I'm subtracting 5 from w plus 5. That leaves me with just w. Equal to 27 take away 5 is equal to 22. Beautiful. So my solution here is 22. This means I can prove my answer. So if I put 22 where w is 22 plus 5 is indeed equal to 27. So it's always a good practice to make sure that you check your answer is correct by just substituting your value back into the equation and check, did I get the answer that's on the right hand side? Beautiful. So now we go to question part B. So here I'm given that m minus 3 is equal to 25. So again, I'm just going to rewrite my question. Equal 25. Again, what do I have in the question? What do I need to do? So I've got a minus 3. I need to do add 3. Remember, I'm doing that to both sides. So let's go plus 3 plus 3. So minus 3 plus 3 cancels each other out, leaving me with my variable as the subject of my formula. So 25 add 3 gives me 28. And again, I can check if my answer is correct. All I need to do now, 28 take away 3 and see, does that give me 25? And the answer is yes. So I know I'm correct. So we go to part C where we're doing a multiplication. So 6k equals 48. So when a letter and a number appears together, there is an automatic multiplication sign in between them. So therefore, this actually reads 6 multiplied by k. So I write that out again, 6k equal to 48. So what I've got in the question, what I need to do. So I've got a multiplication by 6, I need to divide by 6 in my solution, and I also need to do that on both sides. So dividing by 6 on both sides, I get k. 6 into itself goes once, so that's 1k, which is still k. And 48 divided by 6 is equal to 8. And if I know my timetable, like I hope you do, then you know that 6 times 8 gives me 48. But it's very important to show my working out. I cannot stress that enough, how important it is to show your working. So on this question on part D, we've got that h is equal to 9/4 or 9 divided by 4. So I'm going to rewrite my question. So h is equal to 9/4. Here I am dividing by 4. So let's write that down. I've got a division by 4. So I need to first of all multiply by 4. So 4 multiplied on both sides, 4 times h gives me 4h, and that's equal to 4 cancels 4 here, or divided into itself goes 1, so we're left with 9. So therefore, I can see here that what I need to do next, I'm multiplying by 4 now, so I need to divide by 4, which takes us back to the same step. So that means for this particular question, we could have just straight away done 9 divided by 4, since it's already set in that way. But the principle is very important for us to execute. So 9 divided by 4 is equal to 2.25. And that's our exact value. Beautiful. So we go on to some other questions involving a little bit of decimal and negative numbers as well. Principle, however, remains the same. So in this question, again, we're asked to solve each of the following linear equations. We've got in part A, minus 3x is equal to 15. So I rewrite my question again. So, and I love to do that to separate my question from my actual working out. So I've got in my question, so I have multiplication by negative 3. I'm going to need to divide by negative 3. It's very important to pay attention to that sign. So dividing both sides by minus 3, this gives me x. Remember, minus 3 divided by minus 3 will be 1. We do not necessarily write 1x in algebra. It's not incorrect, but it's clear that we only have 1x. Now, what is a positive divided by a negative? A positive 15 divided by negative 3 will give us negative 5. And we can check negative 5 times negative 3 gives us positive 15. So the answer is minus 5. Brilliant. Go to part B, where we've got x minus 9 is equal to minus 4. So rewriting my question, x minus 9 equal minus 4. Look for what I have in the question and what I need to do. So in the question, I have a minus 9. Therefore, I'm going to need to add 9 to both sides. So let's go. Plus 9 plus 9. So minus 9 plus 9 is 0. So we're left with x on the left-hand side. And then we've got minus 4 add 9. Now minus 4 add 9 is the same as 9 minus 4, which is positive 5. And we can check. If I put x here for 5, 5 minus 9 is indeed equal to minus 4. Beautiful. We go on to part C. In part C, we have 0.5x is equal to 8. So rewriting my question again, I'm now going to write what I have. So I have in the question a multiplication by 0.5. That means I need to divide by 0.5. Very simple question, also very easy to get incorrect. So I'm going to divide both sides by 0.5. Now, importantly here to note, so this cancels out, leaving me with just x on that side. It's very important to note that dividing by a half is the same as multiplying by 2. So therefore, 8 divided by 0.5 is equal to 16. Lots of students make mistakes on questions like these because you believe that the answer should be 4. Now we're not dividing by 2, we're dividing by 0.5. So dividing by a half is the same as multiplying by 2. So here we go for this question. Now, similarly in the question before, we recognize that this was already set up for us. So we could just go ahead straight away and divide 6 by minus 2 to get our answer in just one step. So for this question, I'm just going to go and do that. So x then is equal to 6 divided by minus 2 is minus 3. We check. Minus 3 times minus 2, two negatives multiplied together will give me a positive, and this is how I know for sure I am correct in that answer. Amazing. Now we are going to be solving one unknown, but this time we will need to take 2 steps in our solution. Now, if you're following carefully, you would recognize that the questions we did before were all in 1 step. So let's go. Solve each of the following linear equations. For the first one in part A, we've got 2x add 3 equal to 11. Principle applies. So I rewrite my question again. 2x add 3 equal 11. I'm going to write what I have in the question and what I need to do. So first of all, I have a plus 3. I need to take away 3. Then I've got a multiplication by 2. So x here is being multiplied by 2. So I've got times 2. I need to divide by 2. So first step, we take care of the constant first, which is our 3. So I need to subtract 3 from both sides. So again, we are left with 2x on this side, since positive 3 and minus 3 is equal to 0. And then we've got 11 minus 3, which is 8. Check that off. I've taken care of my minus 3. Now I need to divide both sides by 2. So 2 divided by 2 is x is 1, which is going to be 1x, which is the same as x. So we know this cancels out. So 8 divided by 2 is 4. And again, guys, we can check. So if x is 4, that means when I substitute it here and I do 2 times by 4 and then add 3, the answer should be 11. So 4 times 2 is 8, and 8 add 3 equal 11. That's how you prove your answer. Amazing. So we go for the next one. So this one here, I've got x add 6 equal 10. So I need to, so I'm just going to stop writing have do and just execute the operation. So I need to just simply subtract. So this one kind of slipped it way in. I wanted to have 2 steps here, but it's okay. This one is equal to 4. Nice and simple one. Most of the time, like part B, would be like 1 mark questions. So here we go to the next question, where we've got minus 4x add 2 equal to 10. So what I have in the question, what I need to do, I've got a plus 2, I need to take away 2. I've got a multiplication by minus 4. Very important to note the sign there. I need to divide by minus 4 in my solution. So first step, subtract 2 from both sides to keep the balance. I now have minus 4x equal to 10 minus 2 is 8. Check that off. Last step is to divide by the coefficient of x, which is minus 4. So remember, coefficient is what is the number before x. So this side gives us x equal to 8 divided by minus 4 is equal to minus 2, since minus 4 times minus 2 gives us positive 8. Beautiful. And remember, you can check your answer. So we go to part D, where we've got a half x plus 3 is equal to 7. So first thing we do, we've got plus 3, we need to do a minus 3. We've got a multiplication by a half, so I'm just going to write that as 0.5 here. And I need to divide by 0.5, which is the same as a half. And we've done that in another question that we did before. So we go ahead, subtract 3 from both sides. We've got then 0.5x is equal to 7 minus 3 is 4. Check that off. Now I need to do the opposite of multiplying by 0.5, which is dividing by 0.5. Remember we said, so that's x here, dividing by a half is the same as multiplying by 2. So 4 divided by a half is the same as 4 times 2, and the answer is 8. Absolutely brilliant. So x is equal to 8. Well done for getting this far. So we got 2 more examples, and then we are going to do our key takeaways. So first of all, here we are given, we're told, write an expression. So step 1, part A, we are asked to write an expression for the perimeter of this rectangle. We observe that our signs are given in terms of an algebraic expression. So hence the reason, write an expression, because we cannot find an actual answer in terms of a numerical value. Now, key point here is to remember what is perimeter. Remember the word perimeter, the prefix peri indicates around and meter means to measure. So we want the distance around the rectangle. Now remember, opposite side of a rectangle are equal. Therefore, if this side long is 6x, the other side is also 6x centimeters. And the opposite for 4x is also true, that this side is also 4x. This means for 1a that the perimeter is equal to 6x plus 6x plus 4x plus 4x. Now we can simplify since all the terms are like terms. So 6 plus 6 is equal to 12, and 12 plus 4, which is 8, is equal to 20. So this is 20x centimeters as an algebraic expression. Beautiful. Now what we need to do for part B asks us if the perimeter is equal to 60, write an equation and solve it to find x. So this is an application question interleaving my concept of perimeter of a rectangle. So what I need to do then is to make my perimeter that I found in part A equal to 60 and solve it. So part B, we know that 20x is equal to 60. So again, we look in our equation, we're multiplying by 20. Remember, we need to do the inverse of the operation, so dividing both sides by 20. So 20 divided by 20 is 1. 1x is the same as x, so x then is equal to 60 divided by 20 is equal to 3. So therefore, x is equal to 3. And we could substitute that in, and we will see that the answer is indeed correct. Absolutely brilliant. So we're going to do our final example. This time we're focused on the area of a rectangle. So we're told here to write down an expression for the area of this rectangle for part A. Now, area of a rectangle, so area of rectangle is equal to the length multiplied by the width. So even though we only have x there, the principles still apply. So it's going to be 8 centimeters multiplied by x centimeters. So 8 times x gives us 8x, and centimeter times centimeter gives us centimeter squared. So in terms of an expression, the area is 8x. And final section is part B. The area of the rectangle is 88 centimeters squared. Write an equation and solve it and find the side length x. So we know 8x is equal to 88. So what we need to do now is to divide by 8 on both sides. So therefore 8 into 8 is 1, so this side cancels the x. And then 88 divided by 8 is 11. So therefore our answer for x is 11. Absolutely brilliant. And let's just substitute that here. 8 times 11 does give us 88, and that's how we know for sure that we are correct. Absolutely fantastic. So guys, it's now time for our key takeaway. So we talked about the fact that a linear equation is an algebraic equation where each term has an exponent, which is another word for power or index of 1. This means that when we look at an equation, we do not see a power at all, even though the power is actually 1, but we never usually write the 1 there. Now, when we graph a linear equation, we always get a straight line, and this is why we call them linear equations. Now, In order for us to solve a linear equation, we always need to do the opposite of the operation given in the question. So if we're given an addition in the question, we need to do a subtraction. If we're given a multiplication, we need to do a division. If we're given a square, we need to do a square root, and so on. Absolutely brilliant. So guys, thank you so much for getting to this part of the lesson. Remember, it's a 4-part series and this is just part 1. So what you've got to do, make sure you got your notification bell turned on so you see when the other sections are uploaded as well. Also remember to share, subscribe, and also remember, in the description there are some practice questions and solutions for you to engage with as well. Remember, we are also on TikTok. Now guys, until the second section or another video is uploaded, thank you so much for watching.